Assalamualaikum warahmatullahi wabarakatuh. Hi to Dr. Amin. So my name is Muhammad Shukri and I'm a representative from Football. So today I will present you how to do the shallow neural network by using the neural fitting tool on a MATLAB. So without further delay, go to the first step. So first we must have the data set. If we don't have the data set, we can use this example that has been given in the link. So we have the 4 samples and the 2 input array vectors and 1 input vectors. But in this video, I will not use this example for the data set. So I will use the example that has been given by the ML itself. So to run the neural fitting tool, so we must type this code and then start and run it. After we run it, we show you this option. We have the input, output, and computing, pattern recognition and classification, clustering, dynamic instances. So in this problem, in this video, I will explain on the PDF. So after you click it in this PDF, it shows you some introduction, some quick introduction. What is the neural network? So basically, neural network is to help to select data, create and train the neural network, and to evaluate the performance by using the mean square error and regression analysis. So this is the multi-layer perceptron, and so it's give you some quick brief on how the neural network itself. So we have the 2 layers feed-forward network. We have the hidden sigmoid hidden neuron and the linear output neuron on it. So we click next to proceed on the neural fitting tool. So first we must have the data that need to be keyed into the inputs and target. So as you can see, if you have the data itself in the Excel file, you can import it data at this triple dot logo. So in this video, I will choose the example dataset that have been given by the MATLAB itself. So we choose the load example dataset, click on it. So we have many example datasets that are given by MATLAB. We have the body fat, which is to estimate. The problem is to estimate the body fat percentage by using various measurements. But we have the chemical, which is to detect one sensor signal from 8 other sensor signals. So I would like to choose this problem or choose this kind of example dataset for our video. So we have the 498 samples that given and the 8 sensors. So we have the 8 times 498 metrics. The measurements that taken from 8 sensors during a chemical process. So these 8 measurements of 498 samples, we input it into the inputs. We key into the inputs. So we name it as the chemical inputs. So for the target, we want to estimate the 9 sensor measurement by using from the first 8. So the name is we key in the 1 times 498 matrix into the chemical target. So we import the data. As you can see, it's automatically put into the chemical. We take the data, chemical inputs, and chemical target. So this one is the arrangement of matrix. So I will not change the arrangement as it has been the matrix column itself. So we click next to proceed. So after the select data step, we go to the validation and test data. The data set will be divided into 3, which is the training data set, the validation and testing. So we have some quick introduction, a quick explanation of what is the training data set, the validation set, and testing set. So basically, the training data set is the data set that given to the model to train the model network itself. We will update the weight and the bias of the new model network. Okay, for the validation set is to measure the network generalization, and it will stop the training if it become before it becomes overfit. So for the testing, it used to test the predictive power of our model network. So we click next to proceed. So this one we can set and how many percentage we want to divide. So I will not change on this. So the training out in this we set the training 70%, validation 15%, testing 15%. So we click next to proceed. The next step, which is the network architecture. So we will define how many number of hidden neurons we want to be in our hidden layer. So, and you can see if the model performance is not good, we can increase it, the number of hidden neurons. But for this one, I will not change the number. I will use the default number of hidden neurons, the 10, given by this model itself. So if let's say that our model performance is poor, so I will increase the number of hidden neurons. As you can see, this is the hidden layer. So if I set to 100, it will increase the neurons in the hidden layer. So we click next to proceed. So after we select the network architecture, we will train our model network. First, we must choose the training our algorithm. We have the three training algorithm, which is the Lambert-Marquardt, Bayesian regularization, scale conjugate gradient. So Lambert-Marquardt is the advanced backpropagation system, which is more advanced compared to the gradient system. So we'll update the weight for each iteration. So it will require more memory but less time. But for Bayesian regulation, it will require more time. It's suitable more for the difficult and small on the noisy dataset. For the scale, it's require less memory but it's more suitable for the larger dataset. So but for this one, in this video, I will choose the default training algorithm, which is the Lambert-Marquardt. As you can see, we have the description of what is the mean square error and what is the regression error. So mean square error is basically the average square difference between the output and target. So the lower the value are, the better they are. So the regression error is the coefficient of correlation between the outputs and the target. So the higher the number, the closer the number to the number one, so the better they are. So we train our model network. So we click on the train. So as you can see, the training stopped at 18 iteration, and it will validate 6 times until the training stopped at 18 iteration. You can see more clearly on the performance, plot the performance. As you can see, the mean square error for the validation set, the green one, is decreasing every epoch until at epoch 12. It's the lowest the mean square error for the validation for the validation set. But after the epoch 12, it will not decreasing more, as you can see in this graph, it will become higher. So at this point, the validation will occur 6 times. So after epoch 12, 13, 14, 15, 16, and until 18, so the training will stop until the epoch 18. So the best validation performance is at 3.4723. So you can see the final mean square error is small, so it's better at this point. So we can see more better performance by plotting our regression. You can see the R value by plotting the regression. So what is the regression? Regression is the network outputs respect to the training, the validation test, and all target. And training, validation, and test target. So the data should align to for perfect fit. So as you can see at the 45 degree, as you can see the data is aligned at this 45 degree line. Same goes to the validation. Also the data should align at the 45 degree line. So as you can see the R value is above 0.93, so it's a good value for R. So is the output and the target is have higher correlation. So you can also see the arrow histogram. You can plot also the arrow histogram. So the error histogram is the histogram errors between the target values and the predicted value after training a feed-forward neural network. So as you can see, we have the 20 bins in here. The bar is considered as green. So we have the zero error line corresponding to zero error value on the error at this. So as you can see, the histogram is closer. The bar that have highest instances is closer to the zero error. So it's much better. So the error, many samples from different datasets lies next to zero line error. So it's considered good. So after your training and you set, as you can see, this is the result for the training and validation testing. This is our performance of our model network. If you satisfied with, if you doesn't satisfy with the performance, you can train it again, or you can adjust the network size. So if, let's say the training dataset is good, but our test dataset is not good. This means that our model network is overfit. So we need to reduce our hidden neuron. But let's say that the training dataset is worse, is not good. So we need to add some hidden neuron. So we can improve also the performance of our model network by increase our dataset. So we click next to proceed. If you satisfy, you click next to proceed. So after you done after you specify your model network performance, you can generate the MATLAB function. Same also MATLAB matrix or function. You can also simulate it on diagram. You can also generate the code directly, which is whether you want to use the simple script or whether you can advanced script, which have the additional option, which is this is easier because it has the example code on it. So you can refer on it and have additional options which you can add more options on the code. So at this time I will put the advanced script, I will run it. As you can see, it will generate the code that we haven't done by our neural network, our previous neural network. So we'll generate yourself. So you can edit it on here. the same as our tool.